Welcome to the final presentation, Section F, covering primates and evolution of Homo sapiens. So two final concepts. Primate evolution provides a context for understanding human origins. Humanity is one very young twig on the vertebrate tree. Primates are difficult to define unambiguously in terms of morphological attributes. Most primates have hands and feet adapted for grasping. Relative to other mammals, they have large brains and short jaws. They have flat nails on their digits rather than narrow claws. Primates also have relatively well-developed parental care and relatively complex social behavior. The earliest primates were probably tree dwellers, shaped by natural selection for arboreal life. The grasping hands and feet of primates are adaptations for hanging on tree branches. All modern primates, except Homo, have a big toe that is widely separated from the other toes. The thumb is relatively mobile and separate from the fingers in all primates, but a fully opposable thumb is found only in anthropoid primates. The unique dexterity of humans, aided by distinctive bone structure at the thumb base, represents descent within modification from ancestral hands adapted for life in the trees. Other primate features also originated as adaptations for tree dwelling. The overlapping fields of vision of the two eyes enhance depth perception, an obvious advantage when brachiating, using the forelimbs to swing through the trees. Excellent hand-eye coordination. You should look up the definition of that for a better wording than what I just shouted out. The excellent hand-eye coordination is also important for arboreal maneuvering. Primates are divided into two subgroups. The prosimians, probably resemble early arboreal primates and include the lemurs of Madagascar and the lorises, potos, and tarsiers of tropical Africa and southern Asia. The anthropoids include monkeys, apes, and humans. Anthropoidea, the anthropoids, like an anthropod. Anthropology, right? So the oldest known anthropoid fossils from about 45 million years ago support the hypothesis that the tarsiers are the prosimians most closely related to anthropoids. So we see a common ancestral primate in the millions of years ago shown here. So the length of these lines is a representation of time. So lemurs, lorises, and the potos and the tarsiers are the prosimians. And the tarsier is closest to the anthropoids, the New World monkeys, the Old World monkeys, the gibbons, the orangutans, the gorillas, the chimpanzees, and of course the humans. By about 40 million years ago, monkeys were established in Africa, Asia, and South America. The Old World and New World monkeys underwent separate adaptive radiations. All New World monkeys are arboreal, but Old World monkeys include arboreal and ground-dwelling species. New World monkeys have prehensile tails and nostrils that open to the side, while Old World species lack prehensile tails and their nostrils open downward. In addition to monkeys, the anthropoid suborder also includes 4 genera of apes: Hylobates, the gibbons; Pongo, the orangutans; gorillas; and Pan, the chimpanzees and bonobos. I'm supposed to close the parentheses there before the comma. Modern apes are confined exclusively to the tropical regions of the Old World. They evolved from Old World monkeys about 25 to 30 million years ago. With the exception of gibbons, modern apes are larger than monkeys, with relatively long arms and short legs and no tails. Although all apes are capable of brachiating, only gibbons and orangutans are primarily arboreal. Social organization varies among the genera. with the gorilla and the chimpanzees highly social. Apes have relatively larger brains than monkeys, and their behavior is more flexible. Humanity is one very young twig on the vertebrate tree. In the continuity of life spanning over 3.5 billion years, humans and apes have shared ancestry for all but the last few million years. Paleoanthropology is the study of human origins and evolution. I hesitated there based upon the actual meaning. Have shared ancestry for all but the last few million years. Does that mean over the 3.5 billion? I don't think that grammar is correct for the meaning that is intended. We've shared ancestry for the last few million years, and that's it. So the paleoanthropology is the study of human origins and evolution. Paleoanthropology focuses on the tiny fraction of geologic time during which humans and chimpanzees diverged from a common ancestor. Paleoanthropologists use two words that are easy to confuse but which have distinct meanings: hominoid and hominid. Hominoid is a term referring to great apes and humans collectively. Hominid has a narrow meaning confined to those twigs of the evolutionary tree that are more closely related to us than any other living species. There are two main groups of hominids: the Australopithecines, slow, but I think I got it, which came first and are all extinct, the members of the genus Homo, with all species extinct except one, Homo sapiens, us. Paleoanthropology has a checkered history with many misconceptions about human evolution generated during the early part of the 20th century that still persists in the minds of the general public long after these myths have been debunked by fossil discoveries. First, our ancestors were not chimpanzees or any other modern apes. Chimpanzees and humans represent two divergent branches of the hominid tree that evolved from a common ancestor that was neither a chimpanzee nor a human. Second, human evolution did not occur as a ladder with a series of steps leading directly from an ancestral hominoid to Homo sapiens. If human evolution is a parade, then many splinter groups traveled down dead ends, and several different human species coexisted. Human phylogeny is more like a multi-branched bush with our species as the tip of only one surviving twig. And we see some of that represented here in millions of years ago. So present day at the top with Homo sapiens all the way to the right. And we can see the relative characteristic features of the cranium in all of these and how they really are distinctive. And I won't spend any more time on this illustration. You can seek out the textbook and look at the legend. So third, the various human characteristics such as upright posture and an enlarged brain did not evolve in unison. Different features evolved at different rates, called mosaic evolution. Our pedigree includes ancestors who walked upright but had brains much less developed than ours. After dismissing some of the folklore on human evolution, we must admit that many questions about our ancestry remains. And our anthropoid ancestors of 30 to 35 million years ago were still tree dwellers. By about 20 million years ago, the climate became drier and the forest of what is now Africa and Asia contracted and the savanna habitat increased. Some of the major evolutionary changes leading to our species may have occurred as our ancestors came to live less in the trees and spent more time walking on the ground in more open habitats. The fossil record and comparisons of DNA between human and chimpanzees indicate that they diverged from a common humanoid ancestor only about 5 to 7 million years ago. Human evolution is marked by the evolution of several major features. Brain size. Based on skull measurements, researchers have estimated that brain size in humanoids tripled over the past 6 million years. It increased from about 400 through 450 cubic centimeters in hominoids, and similar to modern chimpanzees, to about 1,300 cubic centimeters in modern humans. Jaw shape is another major feature. Our humanoid ancestors had longer jaws, the prognathic jaws, than those of modern humans. These resulted in a flatter face with more pronounced chins. There were also changes in dentition. Bipedal posture. Based on fossil skeletons, it's clear that our hominid ancestors walked on all four limbs when on the ground like modern apes. The evolution of bipedal posture, upright posture, and two-legged walking is associated with key skeletal modifications seen in early hominid fossils. Reduced size differences between the sexes. In hominids, a size difference between females and males is a major feature of sexual dimorphism. On average, male gorillas and orangutans are twice as heavy as females, and male chimps and bonobos are about 1.35 times heavier than females. In humans, males average about 1.2 times the weight of females. Some key changes in family structure. Fossils are effective at documenting evolutionary changes in morphological features, but not changes in social behavior. Insights into social behavior are derived from comparisons between humans and other extant hominoids. In contrast to most ape species, monogamy, with long-term pair bonding between mates, prevails in most human cultures. Newborn human infants are exceptionally dependent on their mothers, and the duration of prenatal care and opportunities for enhanced learning is much longer in humans than in other hominoids. All known hominid human fossils older than about 1.5 million years are from eastern and southern Africa. Most consist of teeth and fragments of jaws, skulls, and other skeletal pieces, with a few spectacular exceptions. Researchers must try to reconstruct human phylogeny from an incomplete record, revising their hypotheses to account for new fossil evidence and data from new research strategies such as molecular systematics. The various pre-Homo hominids are classified in the genus Australopithecus, southern ape, and are known as Australopithecines. The first Australopithecine, A. africanus, was discovered in 1924 by Raymond Dart in a quarry in South Africa. From this and other skeletons, A. africanus probably walked fully erect and had human-like hands and teeth. However, the brain was only about one-third the size of modern humans' brain. In 1974, a new fossil, about 40% complete, was discovered in the Afar region of Ethiopia. This fossil, nicknamed Lucy, was described as a new species, A. afarensis. Based on this fossil and other discoveries, this species had a brain the size of a chimpanzee and a prognathic jaw, longer arms for some level of arboreal locomotion, and sexual dimorphism more ape-like than human. However, the pelvis and skull bones and fossil tracks showed that A. afarensis walked bipedally. In the past few years, paleoanthropologists have found hominid species that predate A. afarensis. The oldest fossil that is unambiguously more human than ape is Australopithecus anamensis, which lived over 4 million years ago. Other fossils of putative hominids go back 6 million years, closer to the ape-human split that molecular systematists estimate occurred about 5 to 7 million years ago. One key question in paleoanthropology is which of the Australopithecines were evolutionary dead ends and which were either on or close to the phylogenetic lineage that led to the Homo branch. Two lineages appeared after A. afarensis, the robust Australopithecines with sturdy skulls and powerful jaws and teeth for grinding and chewing hard, tough foods, and the grass seal Australopithecines with lighter feeding equipment adapted for softer foods. Most researchers agree that the robust Australopithecines were an evolutionary dead end, and the ancestors of Homo were among the grass seal Australopithecines. The earliest fossils that anthropologists place in our genus Homo are classified as Homo habilis. These fossils range in age from 2.5 to 1.6 million years old. This species had less prognathic jaws and larger brains, about 600 to 750 cubic centimeters, than Australopithecines. In some cases, anthropologists have found sharp stone tools with these fossils, indicating that some hominids had started to use their brains and hands to fashion tools. A remarkably complete fossil of a young hominid known as the Turkana boy indicates that even larger brains had evolved 1.6 million years ago. The body had a brain that would probably be over 900 cubic centimeters in an adult of his species, a size between that of Homo habilis and H. erectus. Homo erectus was the first hominid species to migrate out of Africa, colonizing Asia and Europe. They lived from about 1.8 million to 500,000 years ago. Fossils from Asia are known by such names as Beijing man and Java man. In Europe, Homo erectus gave rise to humans known as Neanderthals. Compared to Homo habilis, Homo erectus was taller, had a larger brain, averaging about 1,100 cubic centimeters, and had about the same level of sexual dimorphism as modern humans. The term Neanderthal is now used for humans who lived throughout Europe from about 200,000 to 40,000 years ago. Fossilized skulls indicate that Neanderthals had brains as large as ours, though somewhat different in shape. Neanderthals were generally more heavily built than modern humans. Controversy surrounds the classification of fossils of the humans that lived in Europe, Asia, and Africa from about 500,000 to 100,000 years ago. One school of researchers refers to all regional forms as archaic Homo sapiens, with subspecies names for the regional variants. The other school restricts the name Homo sapiens to later fossils and gives separate species names to the regional fossils. This difference reflects a debate between advocates of alternative hypotheses on the origin of modern humans. Two alternative hypotheses have been proposed for the origin of anatomically modern humans. In the multi-regional hypothesis, fully modern humans evolved in parallel from local populations of H. erectus. In this view, the great genetic similarity of all modern people is the product of occasional interbreeding between neighboring populations. So this multi-regional hypothesis is illustrated in the right here. Homo erectus in Africa, 1.1 to 2 million years ago. We can see some divergence and then interbreeding and leading to African, European, Asian, and Australo-Asian Homo sapiens. The other hypothesis, the out of Africa or replacement hypothesis, argues that all Homo sapiens throughout the world evolved from a second major migration out of Africa that occurred about 100,000 years ago. And we see that illustrated here. The migration completely replaced all prior regional Homo sapien, populations. Good gracious. This migration completely replaced all the regional populations of Homo derived from the first hominid migrations. Better to read it than try to say it. Sorry about that. So the Homo sapiens in Africa about 100,000 years ago with another migration. So both hypotheses recognize the fossil evidence for humanity's African origin. The multi-regional hypothesis places the last common ancestor in Africa over 1.5 million years ago, when H. erectus began migrating to other parts of the world about 100,000 years ago. According to the replacement hypothesis, all of the world's populations diverged from anatomically modern Homo sapiens that evolved from an African H. erectus population and then migrated throughout the world. All of the regional descendants of H. erectus are therefore evolutionary dead ends. A compromise alternative to these extremes suggests that Homo sapiens originated and then dispersed from Africa 100,000 years ago. These individuals then interbred with the regional descendants of the earlier H. erectus migration. This hypothesis predicts that the genomes of indigenous people from around the world today should reflect a complex mix of ancestries. So far, the genetic data have mostly supported the replacement hypothesis. Using changes in mitochondrial DNA, mtDNA, among human populations as a molecular clock, research have reported a time of genetic divergence of about 100,000 years ago. This is supported by nuclear genetic markers as well. The mitochondrial DNA extracted from Neanderthal bones fall completely outside the range of mitochondrial DNA for modern Europeans. These data suggest that Neanderthals contributed nothing to the ancestry of anatomically modern humans in Europe. To choose among these competing hypotheses, comparisons of Y chromosomes in 2001 provided perhaps the most important genetic data so far. The Y chromosome is passed from male to male through the generations of a family with a minimum of crossing over with the X chromosome. Sorry about that. The diversity among Y chromosomes is limited to mutations. By comparing the Y chromosomes of males from various geographic regions, researchers were able to infer divergence from a common African ancestor less than 1,000 years ago. So far, the fossil evidence has been less one-sided than the genetic data in testing the alternative hypothesis. The Western European fossil evidence is consistent with total replacement of Neanderthals about 40,000 years ago by anatomically modern humans known as Cro-Magnons. There were no intermediates suggesting interbreeding between Neanderthals and later arrivals. However, fossil evidence from outside Europe is more ambiguous, with some paleoanthropologists interpreting some Asian fossils as intermediates between older fossils of Homo erectus and the skeletal features of modern Asians.